Welcome to Fiber Tech. As always, I'm Nick. Today is another video in the shed, as pretty much will be for the next, foreseeable future, because this is where the projects are. Today is about making up a mount that is foldable for this vise that I got. This is part of the swap meet haul, which hopefully I'll remember to put something in that corner, if I remember how to use all that sort of stuff. So the essential idea is, off this point here, there'll just be a triangle that will stick out, triangulate back down to the end of this, using a couple of kind of meaty hinges that I have and some big screws that I had to go to the hardware store to buy, and just make something that is still going to work very well as a vise for this shed, because there is no vise in this shed. They're all next door, which is a pain, and it will actually fold out of the way this way and fold flat. So when it is out, it will only come out maybe 500, 600 mil, about half a meter, 2-3 feet, about 2 foot for the Americans watching. So half a meter or so out from the wall, just so it's far enough and it's out far enough that it doesn't interfere with this bench or tool racks or other things, but it's still very functional, and it also allows me to fold it back, so therefore it is completely out of the way. I'm still yet to work out exactly how I'm going to lock that in the outright position, but again, you'll just be coming along for the venture. So, without further ado, I'm going to bring the camera over and show you, and sort of clamp some stuff up to show what I'm talking about and the hardware and stuff that's going to be used and stuff like that. So this is all the hardware I was talking about. So fairly big ass screws to actually attach the timber together, which is just here. So that's going to be the timber that's going to be actually used to make up that triangle. Haven't quite worked out which bit I'm going to use for what yet, but I'll work that out once I start cutting it up. So these are the big screws that are actually going to hold everything together. These are 14 gauge heavy duty timber screws. So actual proper attachment screws. The reason why I went maybe a touch overkill with this is I have to attach pieces of timber that are 50 millimeters thick by basically 100 millimeters this way. So if you're thinking about that's going to actually stick out and the vise is going to be sticking on the end of this, like so, how the heck are you going to attach to this? Well, you have to put another 50, 60, 75 millimeter thick bit of wood on the end. And you move this like that. So you got to do something like that. Now, normal everyday house timber screws are not going to penetrate 50 millimeters. A great example is actually something like this. A pretty typical screw everyone has lying around is only 50 millimeters long. It barely touches into this piece of wood. It's just going to snap off the minute you try to cinch anything up in the vise. So by using proper big construction timber screws, even the 75 millimeter one has enough embarkation, but to make sure that there is no bending, no wobbling, etc., etc., 125 mil screws, which some people may call a touch overkill. But it's making sure that it isn't going to bend and warp. So again, this is going to be sticking out vertically from the wall, well, perpendicular to the wall, to the shelving. So I've got to make sure that this beam flexes and the screws don't just bend. That flexure, all that forces are actually transmitted back to the rather large hinge that will actually be the top hinge. This is actually what I'm planning to use for the top hinge. A big gate hinge essentially that I have lying around. Because the way the triangle is going to work, I can't use a gate hinge like this on the bottom. It just doesn't work. So I'm going to use a very heavy duty 100 millimeter tall door hinge. This is actually a fairly heavy duty one, so it won't necessarily bend and buckle as much. So that's sort of a bit more of the hardware. The other thing is to think about is I will actually have to make up a set of jaws for this side. It has the jaws on this side, but I don't have any jaws on this side, which is a bit of a pain. So basically, again, some bit of wood that I've got lying around. I'll have to find out a bit of these screws. I only have 3 of the screws, so I can't really salvage one from the other side, and I have to find at least one more screw to make up a set of jaws for the other side. So that's the little bits and pieces that are going to be in this video today. So without further ado, I'm going to show you where this is actually going properly, and a bit more of the shape. So that's the hardware covered. It's going to actually what it's going to look like when it's moderately done. So this is a little bit of a mock-up what it's going to look like when it's done. So this bar will be cut at this black line you can see here. Sorry about that. So the vise is actually going to sit basically right about, I don't know if I can get it in shot, but right about there is where the vise is going to finish. This is going to be where it's actually going to mount up, is in this location. So this bit here that's sort of coming off screen, from the black line forward, will be cut off. So the whole thing finishes here. So it doesn't come out of the wall that much. Okay? This is just representing that triangulation, so you can see how it's going to triangulate up. Yes, I haven't got the back piece, the backboard up here, shown as of yet, but there will actually be this cross member, and this, so strut is the best way of putting it, will actually be screwed to a back plane, which will hinge off of this upright timber that you can see in the shot here. So all this upright that's sitting in here, this is what these two timbers will actually attach to give me a very strong point of reinforcement. So nothing will sort of flex. It is gonna flex somewhat in that sort of orientation. That is going to be some rotational, but it shouldn't bend and bow each way because of this big stirrup. Essentially, I'm essentially making a stirrup vise mount as far as I think of it. So that's a bit of a mock-up of what it's going to look like. I'm going to come back once I've got this thing cut, and we can see what it's actually going to look like once we put it together. So we are back after cutting up the bits of wood, which took me about 3/4 of an hour because it's just such thick wood, that's such heavy duty wood. So that sort of now gives people an idea of what this is actually going to look like once it's built. So you can see this is what I was talking about with the brace. This is the strut. So it's not very big. You know, again, it's only 400 mil thick at that. So the vise, this is just the back half of the said vise, is going to sit at this end. Okay. So hopefully everyone can see that. There we go. So you can just see that this is going to sit at the end here. Actually, it's more going to sit like that. Now I think about it. Okay. Again, you're sort of looking at this not quite constructed. So that sort of gives me an idea of which length screws I'm now going to use. Because if I use one of those screws, I can make it work, but it's going to be still a bit long. So, you know, I have to go back to about there where I have to use one screw, and then the other screw is going to be, you know, somewhere probably about there. Okay. That's going to hold this bracket here. Again, I need 2 screws in this area as well. Probably use them from, again, the back. Oops. You can't see that. I'm off frame. So one's going to probably sit about there. And I'm probably going to use a shorter one to do the lower section so it doesn't poke through the bottom and stab people as they're walking past it, because that would be bad. So that's the sort of idea of where the screws are going to go for that one. And then at the top here, I'm definitely going to use 2 125s to make sure that it's going to be strong enough. I don't want this thing falling apart on me. So to give people an idea, that is what the screws are going to look like, the screw setup. So you can see how there's 2 screws in all of the sections where it's needed. These bits of timber are very heavy duty. They're what's called engineered timber, as far as I know, which essentially is bits of laminated wood. It's like plywood on steroids, essentially speaking. It is instead of normal plywood laminations, which unfortunately I don't actually have an example of around me, typically have very thin laminations. If we have a look at this bit of wood, you'll notice how it has very thick laminations, about 1 to 1.5 millimeters thick. This is typically considered engineered timber, which is orders of magnitude stronger than typical plywood. And you may notice also the way I've orientated these timbers, the downward force is in the strongest axis of this bit of wood. So again, because the vise is going to go in here and end of here, and I'm going to be sawing and doing stuff, I want the strongest axis to be here. Again, with this being the way in which the bit of timber I've picked and everything else allows for the best stress, the best transfer stress to be in the best axis. So again, there's a bit of engineering involving here, but nothing, you know, too crazy. So I'm going to pre-drill these, and I'm going to countersink the ends so they sit completely flush at every point, where of course is possible. This one that goes through from the bottom, this one that goes in from the bottom, this one here, I'll have to make a pocket for it using probably a Forstner bit, and then countersink it and stuff from there, so therefore it doesn't poke out the top. So there, you know, there, and there, and there, and you know, 6 screws to hold this together. But this will be very strong, very easy to sort of put in place. So without further ado, I'm going to turn off the camera again, and I'm going to get into screwing and drilling, and when we come back, I'll even have the hinges on. So again, top hinge sits all the way across, bottom hinge is just going to sit sort of like that. Okay, so when we come back, all this is going to be together. Okay, so we're back after I've screwed everything in, and I've realised I may have overbuilt the ever-living crap out of this one. So this weighs, you know, close to 2 kilograms in just, you know, timber alone, let alone with all the hardware and everything that's on it. You know, like, I may have overbuilt this just a little bit. But you can see now how it's all together, how the bottom hinge works and how the top hinge all works. Again, this is going to be mounted up. Sorry. Again, it's going to be mounted up like that on the wall, which will be the next step, of course, which will come up next. Guess I did put the hinge on the right way. So that's sort of the way this is going to work. You can see how it's all going to build up now. I'm yet to still work out my locking mechanism to lock this into place so it doesn't, well, unfold itself. But that'll be something I'll work out once it's actually on the mount. So that's it together with all its hinges and everything on. And yes, I've overbuilt the ever-living crap out of this. I'm making sure it stays in one piece. Anyway, over to the build site, and we will attach it to a wall, hopefully. Okay, so I'm back in frame, hopefully. Anyway, so this is it mounted in its final home. As you can see, the giant brackets. It is currently bolted in place, so it doesn't hinge. That's just done by an M8 bolt, which right now I have to use a ratchet to undo. I'll find out a quicker way of undoing it later. So that's most of what we have to do today. The last bit of the job for today, for this vise, is making a set of jaws. So you can see now how this all works together and how far out and everything it comes in the shed. As you can see, go in there, thank you. So you can see that it does what it's meant to do. It's a vise in the shed, which comes out a little bit further than I was expecting. You know, a couple 100mm extra, but that's fine. Primarily because of this upright here. This upright here is a bit thicker than I was expecting. So there it is in situ, in its final home. I'm going to remove this bit. This helps if I'm in frame. There we go. I'm going to remove this bit, and I'm going to make up some jaws. I'm going to go back to the bench, which is just over there, and I'm going to measure up and make up some jaws, and I'll show them once they're cut. So that's what the jaws now look like, now that they're complete. As you can see, square, 45, recessed screws, so yes, the screws are actually flush with the edge. I actually did this with a Forstner bit, which is a bit that most of you may not actually have come across. Most woodworkers know about them, but if you're a metal worker, you may not come across them very often. But they look like this. A very oddball drill bit shape. Okay? That's what's called a Forstner bit. Not the easiest thing to find, but makes very neat square bottomed holes. If you look at a twist drill, they'll only ever make, like, you know, a chevron at the bottom. They'll sort of make a cone shape at the bottom of the hole. A Forstner bit doesn't do that. It just creates a flat bottomed hole. So the bottom of the hole is perfectly flat, which is cool. It means you can use button-headed screws or other types of screws that don't necessarily actually have a countersink on them, a wedge on them. Just a button head, essentially. Or sometimes bugle head is another term for them. So see how that screw's just got a flat bottom on it? Well, you could recess this using a Forstner bit of the appropriate diameter, of the appropriate size. So it's a bit of a different way of doing it, as opposed to trying to get countersinks and working with countersinks. Now, admittedly, countersinks do have the benefit of being self-centering, so they will actually self-align. That cone sort of makes the bit of the workpiece move into that alignment, so you know that the countersink is in line. So that is the one benefit of using a countersink over a Forstner bit. But a Forstner bit's handy if all you've got is, you know, button head screws like this. It's a way of making recessed screws work. So I will quickly turn off the camera and come back to show you the final product as it is now installed and done. So time to show off the final product. as you can see, it properly hinges now. And this was what I was talking about with the M8 bolt. So there's actually a threaded insert here, so it actually threads into wood. It has a different pattern on the back of it that actually helps it to grip into wooden surfaces. So that's what this M8 bolt threads into. So it's just, you know, a standard M8 bolt. Nothing that special there. So essentially allows me to push it into one position, tighten down the bolt, that locks it in place. I undo the bolt, moves off to one side, and will actually move pretty much flush with that, getting it out of the way of this very small shed. Again, I say this again, this shed is only about 2.5 meters by 6 meters long, so having a giant vise sitting out in the middle of the workshop is handy, except for when you want to move things back and forth. So having it swing away is very useful. So that's the $5 vise. Again, all this material is actually salvaged. I didn't pay. The only thing I had to pay for were the screws, the big construction screws. That was it. Everything else was done by free timber. So all the engineered timber was free. The vise was only $5. The hinges are salvaged off other construction around the house. That sort of stuff. So it doesn't take much to make pretty epic things. Again, just remember, if you can get timber for free that's decent timber, sure, you may have to cut it up in weird ways or use different tools to make it work for you, but there's always a way of using free stuff. Anyway, without that, I will do the outro, as always. So, again, thank you for watching. If you like, subscribe, to the usual shenanigans. And if you would like to support the channel, there is going to be a PayPal link in the description below. Again, you can do a one-off donation as small as 1 Australian cent, or up to a monthly donation, or whatever you feel is necessary. I'll take pretty much anything, because this is not cheap. To give people an idea, these sets of screws, those 2 packets of screws I showed at the start of the video, were worth $23 combined. So that's almost $25 in screws alone just to get this together. So yeah, any sort of donation is helpful. Without further ado, thank you again for watching, and I'm Nick from 5-Bit Tech.